All right, we are jumping into 5.3. We're looking at inclined planes. And the point of this is two-dimensional motion, right? All the motion we've done so far has been motion that is either horizontal or vertical, right? And this chapter, this unit, we've been trying to talk about things that are doing both. So here's an example. This lovely young lady who is sliding down the slide, right? She is moving both horizontally and vertically. And what I want to do today is I want to teach you how we can analyze the forces that are acting on this young lady. So I ask you, what forces are working? Give me one that's working on this young lady in this picture. Sorry, thanks. Give me your hand just so we can... Yes? The force of gravity. And are you comfortable that gravity is pulling directly down on her? Okay. But can you see that we actually make the axis of this motion to be parallel with the slide? Okay? Because it just is easier for us to change our coordinate system and make it parallel with the surface. That just makes it easier on all of us. Okay? So we're calling that going down the slide is positive x, going up the slide would be negative x, going directly 90 degrees off the surface of the slide would be positive y, going south or bottom away from that would be negative y. Does that make sense? Okay, so one force of gravity. What else? What else? Okay, what kind of contact force? There is a contact force. There's two of them actually. Friction. And in this case, friction would be pulling against her, trying to keep her from sliding down, right? Think about maybe those days when you went on the playground as a kid and you had the shorts on or the skirt on, right? And it's bare skin as you try and, oh, it just hurts thinking about it, right? Well, ooh, that's tough. That's tough. Right, that's tough. All right. So friction is our second force. And by the way, we're going to do some more work with friction, actually how to calculate friction. I was hoping to have gotten that done this week, but it didn't work. So gravity, friction, one more force that we've learned that is present, the normal force. And remember, the normal force is going perpendicular to a surface, right? So whatever the surface is, in this case, the slide, it is going directly perpendicular to that surface. If I have this table here, I can show you. This marker is my normal force, right? Are you comfortable if I lift up the table, the marker stays pointing at 90 degrees to the surface, right? But the angle that moves changes, right? As I lift this up or move it down. That chair is kind of getting in the way. Does that make sense? I'm going to show you visually how this works as well. But the point is the normal force is directly 90 degrees off of the surface. Excuse me. So they give you a nice free body diagram. This is in your textbook there on the top of page 138. They show you these three forces together, right? Force of friction going in the negative x direction. The normal force going 90 degrees off of the surface. And gravity pulling straight down. And that gravity piece is the key, the whole key behind these problems that we're going to do together. Because are you comfortable, because this surface moves, gravity starts to have a x and a y component. It actually is moving both up and down and side to side. Not that gravity changes. Gravity still keeps pulling straight down, but because the surface moves, it starts making things want to slide down that surface. Here's an example. Put the textbook on the table, right? Are you comfortable with the table flat? Gravity's pulling directly down into the table, right? If I start to tip this table upward, gravity now is also pulling this textbook down the surface as well as into the surface, right? I know that because if I keep going high enough, that textbook will start moving, right? And I can control, make it move nice and slow, even though Autumn's very nervous, I'm going to make it hit her, right? Does that make sense? There's no other force acting on this besides gravity to cause this motion. It's because the surface is tipping, you get this motion moving down the surface. Does that make sense? And if we know the angle that this guy is moving, this angle that the surface is at, we can actually calculate the x and y pieces of gravity. Does that make sense? That's what we're going to do today. I want to show you this little video piece that helps you to see this. So, here's a box. There becomes an angle, right? Can you see that as these lines stay parallel, this y stays, this angle gets bigger? Are you with me, friends? And the more I move up this, I get more and more x motion, which eventually I'm going to overcome the friction force of this thing, and it's going to slide down. Does that make sense? I can go all the way back. I can take this thing to where it's moving up like this. And now most of gravity is pulling down the slope, and a little of it is pulling it into the surface. At the very end, way over here, I've got hardly none of it pushing into the surface. Almost all of it's going down. This blocks will certainly fall down and hit the ground. If it's glued, that'd be different because there's another force holding it. Yes, you're correct. Does that make sense, my friends? So I want to show you again, this is using here are the forces that we can deal with, right? So I'm going to try this. I tried to make this here. Let's see if we can make it work. So I'm going to take it, I'm going to lift this up. So we got an angle here. Here's my surface, right? This angle, right? Gravity is going to be pulling straight down. Right? So that means I end up with a y component and, oops, wrong one, and an x component of gravity. Are you comfortable this angle right here is the same as this angle right here? This right here, give you an actual marker here so you can see it. This angle here is the same as that angle there. Sir? The sides are proportional? This here? Uh-huh. Over here. This one? Yes. Sure, so it's still going to be our a squared plus b squared equals c squared. Yeah, there's definitely still going to be proportionality to those. So here's my x, and here's my y. Because the x is always parallel with the surface, right? And my y is always perpendicular. Are you comfortable that the normal force is just going to be the exact same amount as this y component of gravity? right? Normal force is perpendicular to the surface. How do I find normal force? How do I find the normal force? Calculate it. It's normal force just matches gravitational force on a nice horizontal flat surface like this desk, right? So therefore, that gravitational piece, right? Because gravity is going both down the surface into the surface because we're on an angle here. Are you with me? All right, let's try an actual calculation. What if I say that this lady, young lady in our slide problem here, what if we say that she has a mass of 60 kilograms and we said the angle of this slide is 30 degrees? Now, where would that be, by the way? If we were talking about the angle of the slide, where would we mean by 30 degrees? It'd be this angle right here, right? So we could say 30 degrees from the horizontal. Is that cool? What if I said 30 degrees from the vertical? What do I mean by that? The vertical line here, I've gone 30 degrees this way. It could be either way, unless they give you directions which way. Does that make sense, my friends? Okay, so I got 60 kilograms of a lady. The slide is 30 degrees from the horizontal. I'd like to calculate the y and the x of gravity. We cool? So let's draw our diagram. Okay, so our slide's going here. We said that that is 30 degrees. Okay. Here's our young lady. We'll just make her into a dot, just to make life easier for us, since I can't draw. What way is gravity pulling this young lady? Gravity's pulling her down, I hope. Okay. So it'll be directly down, right? It'll be moving straight down here, right? That's our force of gravity. How am I going to make my components? Don't let me lose you, Andrew. Stay with me, brother. This is your test on Thursday, right? Okay, so let's make my pieces, right? Because we're going to have directly perpendicular here, and I'm trying to... That was not a very good job of being perpendicular. Yeah, that wasn't very good either. How's that? You okay with that? Okay. And then making it even, making it parallel with my surface from here to there. Are you with me, guys? So there's my x, and here's my y. How did I know how to draw this triangle? I used gravity's force, right? I used the perpendicular force going through the surface. I extended that down, and then I made a line parallel to my surface. That's how I formed my triangle. Yes?
So the angle between the gravitation and y is going to be 30.
That will be 30 degrees. You got it. It's exactly correct. Yes?
Could you draw it opposite? Could you use the x and the y?
I could have done that whole entire... Well, the reason why I would put the y on this side is because I want it to be perpendicular to the surface, right? And because we went up from the right going upward, if I would have drawn it this way, then gravity goes straight down, the y would be here, the x would be there. Does that make sense? If we're doing from the surface this way. If that's my 30 degrees. Because again, what I found with the last class, this piece of actually drawing it was the hard part to start with. Like they could do the rest, but they weren't sure quite how to draw it. So that's why I'm spending more time here with you and those of you watching on the video so you can see. That's the key. Your y has to be perpendicular with the surface. Your x has to be parallel. Cool? And calculating is easy. Let's jump into it. So my gravity x, how would I find my gravity x? How do I find force of gravity first? 9.80 times my 60, right? So 9.80, because that's my acceleration, not a force. Acceleration times 60.0. We'll give some significant digits to make it easier. How do I find this x piece of it now? Sine, why is it sine? It's opposite the angle. Good. So sine of 30.0, we'll add another significant digit there just to make life easier. Okay, do the math. What do I get? That's it. Because it's just the force of gravity, we're taking the sine. This would be the same thing as saying the resultant, right? Times, or the hypotenuse times, right? Same thing. Okay, what's our number? Someone got it for me? 294? That sounds decent to me. 294 newtons. Okay, how about the y component? How would I find the y component? Cool. So 9.80 times 60.0 times cosine of 30.0 degrees. Those are both degrees. Don't forget that. And y is equal to what? Pop it in for me. 509, if we round it, because it's 508 and change, right? 509 newtons, and those are both newtons, because that's force, right? Okay, now does that make sense? At 30 degrees of tilt, would we expect most of the force to be going, and that looks like an X, I'm sorry. Would we expect that most of the weight is still pushing it in the surface or down the surface? If I'm only at 30 degrees. Right, most of it's still pushing into the surface, right? It's only once I get it high enough that I'm pushing down the surface. Does that make sense? And we'll take this further where we can actually calculate. If we can calculate the force of friction, we can know how high do I have to move this to get the object to move. We'll get to that in the future. Does that make sense, my friends? There is a practice problem that's there on page 139 as well. Example problem number 4. Exact same thing. The only difference you might notice with the practice problem is that angle. So they've got something. May I steal this? They have something like this. Right? Here's your box. Here's my force of gravity going right down. They calculate the angle all the way around to here. So you'll see in your exact same piece. All this does is just give you positive or negative. So you don't get confused when you look at that piece. So to review, here's a picture just to review. In my inclined plane, gravity pulling straight down, force of friction going upward, normal force going perpendicular, and here are my two components. My y component of gravity, which is the same thing as the normal force, and my x component of gravity. That's what we got. On a test, you will see something just like the problems that are here, 33 to 35. Like what I just did with you on the slide problem, that's 33 to 35. Give it a shot, my friends.